it is seen gradient descent and its type. Once get the loss value, after the network CNN network will finish, we'll do the optimizer. Here these are the type of optimizer. To avoid the hard work issues, we will go to SGD, then we will get by batch iteration. Then to avoid the problem in the disorder in the mini batch SGD, we will go with the SGD with momentum. Here SGD with momentum. Here this is that like it's like a time series. Here W new equal to W volt minus learning rate, differentiation of loss divided by differentiation of weight volt. Then we will use here batch bias weight equal to bias volt minus the learning rate, differentiation of loss by differentiation of bias volt. So how we can use this formula here? W time, this is the time is current time, so this volt means the previous volt, that means time current time minus 1, then learning rate, differentiation of loss, my differentiation of weight t minus 1. This is the old one. Okay, we will use here exponential weight average like ARIMA and ARIMA like time series. We will use the exponential weight average for smoothing due to face noise issues in the mini batch and SGG. To make the smoothing that issues, we will use the exponential weight average like current time 1, time 2, time 3. So this is the value for the time 1, this is the A1 is the value, time 2, A2 is the value, and continuously it will be like this. So here we use one value, beta is the hyperparameter. So how we can mention A1 value as assigned here, value of T1 equal to A1 like this. Value of T2, how we can take the information from the previous value time 1, so bias into V21 means A1 plus 1 minus beta into A2. So mostly the bias value will be 0 to 1. Sometimes if we take 0.95 beta into A1 plus 1 minus bias into A2, that means A1 bias 0.9 into A1 plus remaining one 0.905 into A2. So if we take A1 this value, or if you reduce the value of the A2, it will, without going too much noise, it will reduce. So the curve will be smoothed and reach the minimum with less loss. So it will go the T2, it will take like BT2 with T3, it take BT3 and at 1 minus bias like this. So the V2 we will take this value here and do the formula. So if we do like this, we will get a smoothing values like this very quickly. The advantage is it will reduce the noise. Instead of going way too much noise, it will reduce here. So the noise will be reduced. It will be quick convergency. So as we say, the gradient descent is the, if we have good hardware, is good for us. SAD also good, is not it's noisy for every record, it's batch wise and it's a little noisy. So in the momentum it will reduce the noise. Then next we will see the diagonal gradient descent.